Section 2.2, Summarizing Important Features of a Numerical Distribution. When you're examining distributions for numerical data, you want to pay attention to the shape, the center, and the horizontal spread. So if I ever ask you to comment on what you are seeing with a distribution, with a graph, I would expect for you to comment on all three of those features. The typical value is considered what we call the center of your distribution. Typically, what do we expect to happen? What is the balancing point? What is the center? Those all kind of are different ways to talk about the typical value. Your variability is your horizontal spread. How variable is your data? If your data is symmetric, if it makes a symmetric distribution, sometimes that's also referred to as a bell curve or a bell distribution, that will have one mound, and the left and right hands will be roughly mirror images of each other. So it would look something like this, or it doesn't have to be a curve, it could be bar graph, but that looks fairly symmetric. You could also have a right skewed distribution, so that would have one mound and a tail that extends to the right. So something kind of like this would be right skewed. And then left skewed would be exactly the opposite. It would have a mound and then a tail off to the left. So when you're classifying skewed, you're always looking for where's the tail going. Is the tail going off to the right or is it going off to the left? So these are all talking about the shapes, the shape of these distributions. So we also could have unimodal. That is just the term for a one mound distribution. So all of those that we've looked at so far are unimodal. This has one mound, this has one mound, this has one mound. Check. Those are supposed to be check marks, not number twos. Now, bimodal just means there are two mounds, so it could look something like this, or the mounds don't have to be exactly the same. You could have one high mound and one small mound, but two very distinct kind of high points would be bimodal. And then multimodal, of course, is anything more than that, so more than two mounds. So maybe you have three or more. Those would be multimodal. Outliers are extremely large or small values that don't fit the pattern of the rest of the data. They should be separated with a gap in a histogram. They could indicate a mistake in the data, but not necessarily. So anytime you see one, you should always make a note of them and investigate further. So someone could have possibly just made a typo in their data entry, and that's why you have this one value that doesn't really fit. Or possibly there really was an anomaly in the data that you collected, and it's a true data point, but that would be an interesting feature for sure to talk about. And then last definition we've got is mode. That's your most frequently occurring data value. That could be numerical or categorical, just whichever value occurs the most. Okay, so after having all of these definitions, what we want to do is we want to examine several distributions, and we want to describe them in all three of those ways. We want to talk about their shape, their center, and their spread. And also we would like to comment on, are there any changes you might make to the scales or the bin widths to more accurately display the data. So let's look at A. A is SAT scores in 2010. We've got the scores across the bottom, and we've got the frequency across the y-axis. So when I look at this one, immediately the shape is what jumps out at me first. So shape-wise, this is definitely unimodal. There's one mound. It's symmetric. Typical value, so what would be the typical score? Again, think of where would you place a balance in order to balance this? Well, anytime you have symmetric distributions, the balancing point should be right about in the middle. So I would say that the typical value, or the center, is approximately 1450 maybe, something between 1400 and 1500. So here we've talked about shape, we've talked about center, and we also want to comment on spread or variability. So how spread out are the data values? Well, let's see, we've got values all the way from a 600 to a 2400. And as far as SAT scores go, scoring a 600 is extremely different than scoring a 2400. And we have everything in between those values being represented here. So I would classify this as a very large spread. Is there anything that I would change about this graph in order to more accurately display it? I don't really think so. I think that there is a really nice visual that's given off here. I think it's easy to read. I don't think that changing the bin widths would necessarily help. I think their scaling is nice, so I would probably leave this one alone. Okay, B, we've got earthquake magnitudes. So they've got the magnitude across the bottom, and then we've got the percent. So notice this one's a frequency histogram. It's counting in percents across the y-axis. So immediately when I look at this one, again, shape is usually the quickest one to point out. This one is also unimodal. One mound. However, this one has this tail that kind of goes off to the right. So I would call this one right skewed. Anytime you have skewness, it kind of messes a little bit with that center or typical value because it won't be right in the center anymore. Between 0 and 7 is right here. The very middle of that would be 3.5. But notice if I put a fulcrum right here, that would definitely not balance it. It would tip right to the left. So I definitely don't want to do that. I think I would probably need to back it up and maybe put my weight, my balancing point, maybe over here more at like the 2. The several heavy values over on the left, that would balance out like the smaller ones over on the right. So, and again, we're just approximating right now. About a 2. Let's see what else. So we've got shape, center, and now spread. So let's see, spread. We have values from 0 to 7 represented here. Now, in general, in the world, the numbers 0 through 7 aren't really that far apart from each other. So it would maybe at first glance seem like this is not a very big spread. But think of the context. Think of the context of a earthquake of magnitude 1 versus an earthquake out here of magnitude 4, 5, even over here to 7. If you think about what that really means in context, there's a very big difference between magnitude 1 and magnitude 7, and we have a lot of those represented here. So looking at it that way, I would probably also classify this one as a pretty large spread. Because the magnitudes 1 through 7 are very different. So notice you kind of need to qualify your spread. Why would you say large or why would you say small? Because the context there matters. One thing I would definitely make mention of here is this one. It looks like we have an outlier around the 6.8 mark. It's separated by a gap in that histogram. And I don't necessarily think that's a mistake. I just think that there was this 1%, it looks like, of earthquakes fall out in that category. But you need to mention it. Something, an important feature like that needs mentioned. Okay, here we've got a histogram, number of students on the y-axis and their scores on the final exam out of 100 across the bottom. Okay, so let's see, shape. This one looks like it's also unimodal. There's one kind of major mound. This one to me looks like it's got some left skewness going on. The typical value, center. It looks like maybe we would need to place our fulcrum somewhere here in the 60 maybe area. spread? Well, we have scores all the way from 0 to 100 that are represented here, and that is actually every score you could possibly get on the test. You can't get negative scores, and very unlikely you could get over 100. So we've got the whole entire kind of gamut of scores represented. So again, I would say this is large. Now on this one, something does strike me about the bin widths that I, as an instructor, don't like. Something that I would change. They're counting by 20 here, and so that lumps everyone who scored a 60 all the way up to an 80 into a single category. So I would have students who were scored a D lumped in with all the students who scored C's all the way up to almost a B. And then I would have students who scored barely a B and all my A's also in the same category. And I just feel like that's not a great breakdown. I personally would change these bins to 10s so that the letter grades would be broken out. Because as a teacher, this right here really doesn't, I don't feel like it gives me any information. Not a lot for sure.